Evaluate the definite integral from pi by 2 to pi e raised to x into 1 minus sin x upon 1 minus cos x with respect to x. With reference to these various types, let's now try to integrate this new function. We have a product to integrate. One of the factors is a complicated trigonometric function and the other factor is e raised to x. Applying the product rule, the integration by parts as it is on it may not be that easy. But look at this e raised to x. What is special with e raised to x? This is the only function whose derivative as well as integral is the same. E raised to x derivative is same, e raised to x. Let us make use of that fact and hope this can be changed into this pattern. Whenever an e raised to x is given as one of the factors, we hope to change the other factor into the form of sum of a function and its own derivative. Let's try to do so. I'm just applying 2 theta formula to these two, sin x and cos x. Sin 2 theta is 2 sin theta cos theta. Theta has to be taken as x by 2 now. Sin x is 2 sin x by 2 cos x by 2. Similarly, cos 2 theta is 1 minus 2 sin square theta. Theta is taken as x by 2 as the angle here is x, half of the angle. Here this 1 and 1 get cancelled and minus of minus, the term is positive in the denominator. And the numerator we have two terms. Let us now separate this into two terms. This 2 sin square x by 2 I'm giving to both like this. So in the second one, what's happening? These coefficients 2 and 2 get cancelled. 1 sin x by 2 cancel with this 1 sin x by 2 and the remaining sin x by 2 make it cot x by 2. Cot x by 2. And here, this 1 by 2 half you keep away. But the remaining 1 by sin square x by 2 is cosec square x by 2. Now look at these two functions, two terms we have made. Now, what is the derivative of cot x by 2? Derivative of cot x by 2 is minus cosec square x by 2 into half. Why should there be a half? Because of the chain rule applied on the cot x by 2 derivative. Cot x by 2 derivative should have been minus cosec square x by 2. There is no minus seen here. No need also because our fx is minus cot x by 2. So the derivative of minus cot x by 2 will be positive. And this x by 2's chain, completion of chain gives this half. Oh, this is exactly fitting. Fx and f dash x. Yes. And then what this method says? This method says multiply that e raised to x inside, give to both terms and separately integrate. Okay. Let us separate them. E raised to x is multiplied with this and e raised to x is multiplied with this, separated. But in the method, it is said the term with the derivative, keep it intact. Don't touch. But integrate only the other one, the one with function. Here function was cot x by 2 and derivative was cosec square x by 2. So this is the one to be integrated further. This is still a product. So we have to apply product rule, that is integration by parts. Trigonometric function and exponential function are the factors u and v. Trigonometric and exponential, T and E. What is the hierarchy? Trigonometric should be the first one. Evaluate is a clue word. In this hierarchy, we should keep the functions involved in the product rule. So trigonometric, then exponential. Yes, it's already in the form. So we will keep this as first factor and this as the second function. Integrate using this formula. First function into integral of second minus integral of derivative of first into integral of second. Okay. So keep this minus there itself. Minus first function cot x by 2 into integral of e raised to x is e raised to x minus integral of derivative of cot x by 2, that is minus cosec square x by 2 into half into integral of second one. So this integration still has to be performed. That is how the product rule is always. Alright. Now let's look at this step. This minus this minus, this again minus. Once you open this bracket, this term will be a negative term. And this term is positive term. These are both same. Exactly the same with opposite signs. They will cancel. What you are left with is only this one term. Here it is. Cot x by 2 into e raised to x. Oh, integration is over. But this integration is a definite integral. We have to evaluate it numerically. How? Give the upper value pi and the lower value pi by 2 as the upper limit and lower limit. Giving pi first, cot pi by 2 into e raised to pi minus, then lower value pi by 2 given. Cot pi by 2 by 2 is pi by 4, e raised to pi by 2. Now, values. Cot pi by 2 is 0. So this first term will be 0. And cot pi by 4 is 1. 1 into e raised to pi by 2. This minus is already there. Another minus was already here. So which altogether make plus e raised to pi by 2. That is the definite integral value of this given integration. Found it useful? Don't forget to subscribe Marie Joseph channel for variety of examples and various topics.